Let's discuss each of the available processes and their related benefits. In order to understand pulsing processes, we need to understand the basic principle of GMAWP. Pulsed MIG is a modified spray transfer process. Pulsed transfer continuously propels drops of molten metal across the arc. In pulsed spray transfer, the power source rapidly switches the welding output from high peak current to low background current. The peak current pinches off a spray transfer droplet and propels it toward the weldment for good fusion. The background current maintains the arc, but is too low for metal transfer to occur. With no metal transfer, the weld puddle gets a chance to cool. AccuPulse is a new process technology created by Miller for pulsed MIG welding that monitors, controls, and modifies pulsing parameters hundreds of times faster than previous pulsing technology. AccuPulse benefits semi-automatic, automatic, and robotic welding in manufacturing autos, truck and trailer, rail cars, light gauge manufacturing, fabrication shops, agricultural, and construction equipment. AccuPulse provides shorter arc lengths along with more focused arc column, which in turn provides significantly improved puddle control and arc stability. AccuPulse also improves welding in tight corners without arc wander. Its quick adaptability when welding over tack welds eliminates spatter and stumbles. The AccuPulse program works by specifying key variables for the application at hand. The welding power source then chooses from a vast library of data and selects the optimum pulsing parameters for the selected variables. AccuPulse samples the arc voltage 10,000 times per second during the peak and background time, allowing it to adapt hundreds of times faster than other systems. In addition to using speed for improvement, AccuPulse adjusts the current to a predetermined level at the beginning of each peak and background phase. In other words, AccuPulse ramps the current up or down to stay within the range of the proper level for a specific wire diameter and type, wire feed speed, and gas combination, which means a proper arc condition is much more likely. Welding machines are usually classified as constant current or constant voltage. A constant current or CC machine will vary its output voltage to maintain a steady current, while a constant voltage or CV machine will fluctuate its output current to maintain a set voltage. GMAW pulse welding allows the use of CC in the MIG process by rapidly alternating between a target peak current and a target background current. This rapid transition detaches a droplet of molten metal and transfers it across the arc. As it is a modified spray transfer, it is possible to prevent short circuits and eliminate spatter. CV welding typically allows short circuits in the arc. The shorter arc lengths attainable in CV meant faster travel speeds for manufacturing. AccuPulse and its variations allow the combination of spatter control and faster welding travel speeds by using both CC and CV in the same pulsed waveform. Let's look at how the CC and CV waveforms work together. Once the target current is reached at the beginning of each pulse phase, the CC control turns off and the CV control loop turns on. The CV loop modulates the current to achieve the target voltage, allowing AccuPulse to create the desired wave shapes with arc characteristics that optimize desired arc performance. With the ability to better regulate pulsing parameters, AccuPulse allows operators to maintain a shorter arc length, regardless of stickout, with a more focused arc column. This results in greater speed and control. AccuPulse gives operators superior control over the weld puddle, reducing spatter and cleanup, ultimately saving time and money. In automatic applications, AccuPulse improves welding over tack welds, where the arc length can adapt rapidly without stumbling and causing spatter or tip burnback. AccuPulse reacts so quickly that it increases power immediately and keeps the arc above the tack to maintain productivity and weld quality. In most applications, holding a shorter arc length reduces overall heat input, improves control, and increases travel speeds. This may enable superior welding on thinner materials or using the next larger diameter electrode. For example, AccuPulse permits welding steel out of position with an 052 diameter wire instead of the 045 wire commonly used, and larger diameter wires cost less and offer improved feeding performance. To recap, AccuPulse makes shorter arc lengths possible, allowing faster travel speeds and greater control, especially when welding out of position. It allows better puddle control, directed arc, and is more tolerant of contact tip to work variation. It adapts extremely fast over tack welds. Larger wire diameters can be used, which saves money. There's no arc wandering in tight corners and a stiffer arc plasma column. It's more tolerant with poor fit-up and gaps and provides perfect performance with through arc seam tracking. AccuSpeed is a variation of the AccuPulse process. AccuSpeed uses the same CV adaptive scheme and waveform technology as the AccuPulse process. The AccuSpeed waveforms, however, were developed for the type of arcs needed in automotive frame welding applications. It can be used in manual applications when welding out of position, requiring a tight, fast freezing arc. Tight driving arcs can be directed into the joint and keep the arc stable at the high travel speeds used in automotive frame welding. In general, the AccuSpeed waveforms have a lower average voltage and amperage when compared to the similar AccuPulse waveforms, reducing high heat input and warping. AccuCurve is another variation of the AccuPulse process. The process still uses the same CV adaptive scheme and waveform topology as the AccuPulse process. The main difference is the current transitions from peak to background and from background to peak. In AccuPulse, they were done with linear CC transitions of amps per milliseconds. In AccuCurve, they are done with curves or transitions of amps per millisecond squared. This curved transition aids in ball detachment and gives the transfer a softer feel without sacrificing the tight arc lengths that allow for better puddle control. The waveform is primarily used on aluminum and stainless steel. The machine is capable of welding using standard pulse. A small percentage of end users may require traditional pulse welding for procedure qualification records or nickel and high alloy material. Metal core is a special type of wire used for increased deposition rates and efficiency over solid wire. A more focused arc allows higher travel speeds. During the metal transfer, the drop is smaller, more focused, and makes the weld puddle easier to control. This allows the user to take advantage of metal core wires' faster travel speeds, higher deposition rates, and decreased need for post-weld cleanup. Metal core can be used in MIG, AccuPulse, and RMD processes. Short-circuit MIG is a low-heat input process. The low heat gives advantages when bridging large gaps or welding on thin materials. Short-circuit transfer typically generates some spatter that may or may not be acceptable on light-gauge materials. The access provides a superior MIG arc than conventional transformer-based welding equipment. Regulated metal deposition, or RMD, is an optional software-based, precise wave-controlled short-circuit transfer and eliminates spatter. It's a method of predicting when the short is going to clear and then rapidly reacting to this data, changing the current levels. Early prediction of the short clearing enables quick reduction of the available current, minimizing the arc force and reducing the amount and size of spatter. The molten puddle is calm, reducing splash and cold lap effects normally associated with short-circuit transfer. RMD can be used with very thin materials or to make a small, low-heat input bead on thicker material. It can help compensate for poor part fit-up and less than ideal weld joints. RMD allows better gap filling as well as spatter elimination or reduction. It provides more distortion control and less heat into thin workpieces. RMD has excellent performance on stainless and is very tolerant to contact tube-to-work distance variation. It can replace TIG processes in some applications and can be combined with other access options.